The properties of parallelograms. The first one is opposite sides are congruent and parallel. What is the second property, Cooper?
Opposite angles are congruent.
Opposite angles are congruent. You are correct. Sorry you weren't looking. Opposite angles are congruent. What is the third property? It deals with angles, but they are not opposite. Go ahead.
Consecutive angles even or even?
Yeah, consecutive angles, we call it supplementary. Consecutive angles are supplementary. Wonderful catch. And then last, the last one. When you do it, what is the last one? Go ahead, Cooper.
Diagonals bisect each other.
Diagonals bisect each other. So on your quiz, make sure you write bisect each other, or diagonals are bisected. It has to be a completed sentence and a completed thought for it to be correct. You're not writing them out. You're going to more so be doing state which theorem you use to show that you have a quadrilateral is a parallelogram. And those properties are essentially what proves that you have a parallelogram. But if you have any 5 of these, you have a parallelogram, and you would write which one you have to prove you have a parallelogram. So in our first question, we're only doing the first today, what do we have that could show we have a parallelogram? We have opposite angles are what? Congruent. So that's what we write. Opposite angles are congruent. That's it. Now for the others, just to refresh your memory, this is my beautiful parallelogram. You're welcome. If you have sides marked congruent, what is the reason that this is a parallelogram? Because the opposite sides are congruent. But it doesn't say anything about parallel. So this will be just opposite sides are congruent. If it had the dash and the triangles, now it is a parallelogram because opposite sides are congruent and parallel. If it just has the triangles, okay, just pretend that looks pretty, it would be because opposite sides are parallel. Okay, so make sure you know the difference. Number 3, in exercises 3 and 4, find the value of x that makes the quadrilateral a parallelogram. I had a lot of questions about this on the quiz. It just is asking, if this were a parallelogram, what would x be? Right? What would I do if this were a parallelogram? I would set them equal. So that's what we're going to do, is we're going to set them equal. 3x plus 5 would be the same length as 41. All right? So then we would solve for x. So I'm going to subtract 5. 41 minus 5 is 36. Divide by 3 and x equals 12. So if this were a parallelogram, x equals 12. That's it. If you plugged it back in, you would get that this length is 41, which is what it's supposed to be. You can cross out 14 and 15 on this page. It's just a printing error. I don't know why it's there. Go ahead and flip to the next. On the front page, there's like random things under this picture, right? It says 14 and then like some, just cross that out. All right, so you will have a question like this on your quiz and your test. A couple things will be different. You will not have to explain. And then also, this angle up here, it will not be drawn on the picture for you. So please, if you don't listen to a single thing I say, the number one thing that students get wrong on this question, is that they don't read. Under the picture, it will not be in the picture. Under it, it will say the measure of angle DAB is 120 degrees. Without that, you don't have enough information. Make sure you read on your quiz and your test review under the picture. Capiche? Okay, thank you. All right, so knowing this, we're going to find the lengths of all these. We're just doing the evens today on your paper. Find the length of CD. Is it a side or a diagonal? It's a side, and its length is 16. We got AE. Is it a side or a diagonal? Diagonal, and its length is 7. Find the measure of an angle BCD, which is this whole angle. Is 120. Is that what he said? It is congruent to the angle across from it. It is 120. Good. And then to find ADC. What do we have to do?
Add 43 to 120 and subtract it.
Not quite. That would tell you what this angle is. This is a good idea. It's even simpler than that.
Oh, I know.
Go ahead.
Never mind. What?
What do you know about the angles right next to each other? They're called consecutive. They're supplementary. What's the measure of angle A? 120.
60.
So that means this angle is 60. Because 180 minus 120 is 60. If I asked you, Jace, to find this angle, then you'd be doing it a little bit longer of a way, but it'd be correct as well. How would I ask it? I would say find the measure of EDC or possibly BDC, something like that. How would I find, so Jace has one way. What is another way to find what I just highlighted in red? It's simpler though. What's the measure of the whole angle? 60. How much of the angle do you already know? 43. So how would you find what's left? Subtract it. Okay, so make sure you are ready for that. The other thing to know for this quiz and test is alternate interior angles. Remember that these sides are parallel and there's a line touching parallel lines. So that creates alternate interior angles. So like this angle is 43. This top angle would also be 43. So remember how that works. Okay, they would be on opposite sides of the transversal. Okay, they might ask you that, I think on your test review, not necessarily on your quiz. So that brings us to 7.4. This part is not review. This is new information. It is not on the quiz today. Okay, it will be on your test. So we were still on the same page, Pikachu. Special parallelograms, we've been talking about what they could be. The very first one is a rhombus. You'll see the picture right there. Go ahead and write in rhombus on page 2. Right there. Rhombus, it is a parallelogram with 4 congruent sides. So go ahead and write that in. It is a parallelogram with 4 congruent sides. It is a parallelogram with 4 congruent sides. Okay, so this is a special type of parallelogram. Okay, so all of the properties that a parallelogram has, a rhombus also has because it's a special type. Okay, and the next one is a rectangle. A rectangle is a parallelogram with 4 right angles. So a rectangle is a parallelogram with 4 right angles. So a rectangle is a parallelogram with 4 right angles. Make sure you've drawn in the right angles as well as the congruent sides for a rhombus. So make sure you drew the right angles and then all the dashes. Okay? So, again, these are types of parallelograms. So they have all of the properties of a parallelogram, the opposite sides being congruent, yada yada. If a rhombus and a rectangle got together and had a baby, what would it be called? A square. A square is a parallelogram with 4 congruent sides and 4 right angles. So go ahead and write that in. It is a parallelogram with 4 congruent sides and 4 right angles. So it is a parallelogram with 4 congruent sides and 4 right angles. So a square is a very specific type of rectangle because a rectangle just has 4 right angles. So whatever property a rectangle has, a square also has because a square is a rectangle. The same thing over here. A square is a rhombus. Whatever property a rhombus has, a square has as well. Okay? You're going to see that here in a Venn diagram. You remember seeing them when you were younger. These are all parallelograms. There you go. All parallelograms. How many properties does a parallelogram have? 4, right? So a rhombus has the properties of a parallelogram and then some. This is not on your notes. We're just talking about it. A rhombus is a type of parallelogram, so it has all the properties of a parallelogram. Okay, the same thing with a rectangle. And they get together and they make a square. So what were some of the properties of a parallelogram, Sam? You just said something. That's why I called it.
I got you.
Connor.
They all have four sides.
Okay, a quadrilateral has four sides, yes. But specifically, what does a parallelogram have? What properties does it have?
Opposite sides.
Opposite sides are congruent. Look at that. On all of them. Opposite sides are congruent. Even on a rectangle, opposite sides are congruent. What's another property of a parallelogram?
Opposite
Angles are congruent.
Opposite angles are congruent. Look, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90, 90. It's harder to see over here because we don't have anything labeled. What was another one?
Consecutive angles are supplementary.
Consecutive angles are supplementary. What's 90 plus 90? 180, which is supplementary. Okay, and then we don't have any diagonals drawn yet, but all of those properties apply to a rhombus, a square, and a rectangle. Okay, they've got a couple extras, but before we get to them, we're going to classify a quadrilateral. You'll need to be able to do this on your quiz, or on your test, not your quiz, sorry. Classify a quadrilateral, explain your reasoning. What are we thinking that this quadrilateral is? Is it a rhombus, square, rectangle, just a parallelogram? It is a rhombus. Why do we think a rhombus?
Because it's got equal sides.
Because it has equal sides, but why is it specifically not a square?
Because it's not 90.
Yeah, there's no 90, there's no right angle. So we have to explain that. So a rhombus, because it has all congruent sides, but no right angles.
Did you do this in the quiz?
On the test. None of this new information is on the quiz, it's all on the test. So, rhombus because it has all congruent sides, but it does not have any right angles. Okay? So, let's talk about the properties of a rhombus. So the first one, it has all the properties of a parallelogram. So go ahead and write that down. Number one, has all the properties of a parallelogram. Has all the properties of a parallelogram. So right off the bat, how many properties does it have?
5.
Well, it has 4. Okay, so that one's not new. It has all the properties of a parallelogram. It also has all congruent sides, or all sides congruent, however you want to say it. All congruent sides. The next two are new. Okay, and it's specific to a rhombus. Okay, a rhombus, its diagonals are perpendicular. So its diagonals are perpendicular. What does perpendicular mean to me? Thank you, Mari. They intersect form 90. You might have said it, but you only said 90. They intersect and form 90. Okay, intersect and form 90. What I want you to do, you don't have this picture right next to it, but you do have a picture below, like in an example. I do want you to write that they form 90 degrees. So just go through. That means all of these are 90 degrees. Okay. The diagonals intersect and form 90. Okay, this only applies to a rhombus and what other shape? What shape is and a square. And we'll talk about a square in a second. But it does not apply to a rectangle. It does not apply to everyday parallelograms. It applies to a rhombus and a square. The fourth one is that the diagonals bisect opposite angles. The diagonals bisect opposite angles. Diagonals bisect opposite angles. Diagonals bisect opposite angles. So I think you're given an angle in the bottom picture, the number 61. I think it's here. Am I right? Okay. So in a rhombus and a square, that's it. In a rhombus, the diagonal cut the outer angle in half. So if this piece is 61, you can go ahead and write in that the piece right next to it is 61. which means the angles across from it, because this one is alternate interior with this one, and this angle is alternate interior with this one. So those would be 61 and 61 as well. But again, that's in a rhombus and not in a regular parallelogram. Okay? We are going to move on to a rectangle. This is on the next page. You can cross out the example in the top of that next page. Number 1. So at the top of this page 4, you can cross out the extra example at the top. We're just going to do the properties. A rectangle has all the properties of a parallelogram. Has all the properties of a parallelogram. That is number 1. So again, those 4 properties that we memorized a while ago. All right, number 2. What do we know about the angles in a rectangle? They are congruent and they're 90. Yeah. So all the angles are 90. You could say they're all congruent, same thing, as long as you know they're 90 each. So all the angles are 90. And then the last one is specific to a rectangle and a square. It is that the diagonals are congruent. The whole diagonal is congruent to the whole diagonal. So remember that property of diagonals still applies here, meaning it's been bisected. So if I just took this piece and it was 5, what would the full length of AC be? 10. And what would the length of DB be? 10. DB would be the whole line. So the whole diagonal is congruent. Okay, the whole length. All right, we are going to use that on the next page and actually do an example. So we are going to do the example at the top of page 5. In rectangle QRST, the length of QS is 5x minus 31, and the length of RT is 2x plus 11. What do I know about the diagonals of a rectangle? They're equal to each other, so what do I do here? Set them equal. So 5x minus 31 is equal to 2x minus 11. Move the smaller x. 5x minus 2x is 3x. Add 31. 3x equals 42. Divide by 3. And x equals 14. Did it ask me what x was? No. It says find the length of the diagonals, so we got to plug it in. The length of QS is 5 times x minus 31, which is, what is it? I thought you said what it was. Yeah. Yeah. I would make sure you still plug it into both, just to make sure you're correct. But either way, 2 times 14 is 28, plus 11 is still 39. They should be equal because we said they equal, right? They're congruent to each other.
So you have to vote.
No, I'm telling you, if you made a math error here and you got the wrong x, plugging it into both would tell you that you got the wrong x. Or if you made a math error here, I would recommend you plug it into both, but you do not have to, but you do need to label both of them. That's what I asked for. All right, a square. Nothing special about a square other than it has all the properties. All the properties of a parallelogram, all the properties of a rhombus, and all the properties of a rectangle. So I'd write that in. So on your test, when there's a matching section with properties, make sure if you say it applies to a rhombus, it also applies to a square. If you say it applies to a rectangle, it also applies to a square. So all properties of a parallelogram, all properties of a rhombus, and all properties of a rectangle. All properties of a parallelogram, all properties of a rhombus, all properties of a rectangle. All right, at the bottom of this, you can cross out that example. We are going to talk about something. So above everything, there are quadrilaterals. Can someone tell me what a quadrilateral is? It's a what?
Let's go 4 sides.
It's a 4-sided polygon, right? 4 sides. That's the qualification of a quadrilateral. It could look pretty like a square. It could look 1, 2, how can I do this? 3, 4. It could look weird. As long as it has 4 sides, it makes a quadrilateral. There are special types, like a parallelogram, which we've been talking about. There are 4 properties to a parallelogram, but the definition is that it has 2 pairs of parallel sides. Miss Marshall, why do I care? Here's why. We're about to talk about a trapezoid, which is not a parallelogram. I just need you to know when we talk about it for a second, it is not in the same category as a parallelogram. And you're going to see why. Okay, trapezoids are important. We're going to use them in volume. Volume is finding like the inside, the space inside of a shape. So we're going to introduce trapezoids today. A trapezoid, okay, is a quadrilateral with only 1 pair of parallel sides. So I want you at the bottom to label a trapezoid. It is a quadrilateral with only 1 pair of parallel sides. It is not a type of parallelogram because it only has 1 pair of parallel sides. We're writing it at the bottom. So it only has 1 pair of parallel sides. And then I would draw the picture to the best of your ability. So a quadrilateral with only 1 pair of parallel sides. And then I would draw a picture. So 1 pair of parallel sides. We call those parallel sides the bases of the trapezoid. I would label them on your picture. We call the parallel sides your bases. It's going to be important because when we go to find the volume, you have to end up adding the base lengths, which we'll talk about later. But the bases are the parallel sides. Okay? I do believe this term is in the term section on your test. So make sure you go back and look at it. Okay. Is a trapezoid a type of parallelogram?
No.
It is not. Okay? It is not. You're going to clear your desk of anything besides a pencil and a calculator.